Yay, it's calculator applications day. So we are going to go through a really quick set of notes. It's just one page. Yes. And hopefully this helps you out with your calculator. Okay, so the first thing we have to do is graph this function, y equals 5 times 2 to the x minus 7. And we have to sketch a complete graph and state our window dimensions. Okay, so we're going to the calculator. Let me memorize that. Okay. So I'm going to y equals, I'm clearing out whatever's in there. And I want 5 times 2 power caret x. Okay, I want to arrow out of my parentheses, not just kidding, arrow out of my power. And then I'm going to, what am I going to do? Okay, close my parentheses. I had a brain fart. And then, what was it? I forgot. Minus 7. It's going to be a long way. Minus 7. Okay, so then we want to see a graph of this. And we want to make sure that you get a nice, pretty graph. So you can change your window by going to Zoom 6 and picking the standard window. So I'm going to hit Zoom up here at the top row. And then I'm going to pick 6 for standard. And I have a nice, it goes from -10 to -10, -10 to -10. So if your window was weird, just hit Zoom 6 and you get a nice window. Okay, so I can see that I've got a shift down 5 units, and I also have a lovely vertical stretch by a factor of 5. Okay, so I'm going to draw this on my little sketch pad. Not sketch pad, my assignment. Okay, so look here. My horizontal asymptote is right here. Okay, this is the line y equals -5. And then I've got my y-intercept at 0, -2. We can check that using the table. So right here you can see 0, -2. And if I look closer at where my x's are going, oh, did I say -5? It was -7 for the asymptote. I was thinking of the stretch by 5, but the asymptote is at y equals -7. Because these y values are getting closer and closer and closer to -7. See, they're getting to be really close to -7. Look at that graph again. Sorry, I misspoke. This horizontal asymptote, I'm like half asleep still, I guess, is at y equals -7. And I said -5 and that was wrong. Sorry, my bad. Okay, so go to your paper, and we're going to draw this. So my window is going from -10 in the x direction to +10 in the x direction. So what I write in this little x is that I'm going from -10 to +10, like side to side for my x's. And then for my y's, I'm also going from -10 to +10. So that's what I write here. Okay, you didn't remember how to do that. Okay, now my graph was going like this. It crossed at 0, -2, and its horizontal asymptote was down here at y equals -7. And it's going like that. Okay, so my y-intercept was 0, -2. Sorry, I'm going to sneeze. My horizontal asymptote was y equals -7. I have growth because my base is 2. I'm multiplying by 2 every time and doubling. My domain is all real numbers. And my range is y values that are greater than -7. And that's, we have to label this point, 0, -2. Okay, so that is what it means by saying a complete graph. Okay, I have my axes, I have my asymptote, I have my y-intercept, and my asymptote and intercept are labeled. Okay, that's what it means, complete graph. All right, here's another example. Okay, so now I'm going to put this in the calculator, and we're going to do the same thing. So I go back to y equals, clear it out. Oh, I already forgot what it is. Negative 12, 1/3, 2. Okay, so I'm putting in negative 12. Make sure you're using the little baby negative, not the subtraction sign. Open parentheses, 1 divided by 2, close parentheses, power caret x. Shoot your arrow out of your power, plus 2. Okay, there's a lot going on here. Now I'm going to go to my graph. Okay, you can see that we had decay, but it was reflected, and it's been stretched, and it's been shifted up 2 units. So the parent started over here. Yeah. Okay, the parent started over here. Okay, and then we stretched it so it went like, and then we reflected it, and then we shifted it up too. Okay, that was a lot. Okay, so I can't really see my y-intercept very well. I don't know if I can see it very well, but I can tell where my horizontal asymptote is. It's at y equals 2 because I had to shift up 2 units. Okay, let's see if we can find the y-intercept from the table. So I'm going to go second graph to my table. Oh, goodness. Oh, there it is. So 0, negative 10 is my y-intercept. That is just barely, barely, barely in my window. It's on the edge of my window. All right, so I'm going to go to my graph on my paper. I'm going to sketch. I'm still going from negative 10 to positive 10 and negative 10 to positive 10 in the y direction. And then my y-intercept was way down here at 0, negative 10. And then I was going to my horizontal asymptote, which is up here at y equals 2. So it's going like that. Nope. Okay. So my y-intercept was 0, negative 10. My horizontal asymptote was the line y equals 2. My domain is all real numbers, and my range is y values that are less than, because it's under 2. Okay, so now we have to describe all of the transformations for the function g of x compared to its parent f of x. So notice that they have the same base of 3. It's 3 that's being raised to the power both times, so they have the same base. We can see these transformations in the calculator. What we remember is that the a value is in charge of stretching, vertical stretching, and vertical compressing. And the a value also does rocks if it's negative. Okay, the base is in charge of growth or decay, but that's not a transformation. That's just part of the base. And then the plus 5 is my shift. Okay, but we can look at a picture of these two compared to each other. Oops, I don't want to do that. I want to go to my calculator. Go to y equals, clear that out, negative 1.7, open parentheses 2, power caret x, shoot out of the power, close your parentheses. Was it plus 5? Yeah, plus 5. Okay, so now I can see that. That's my transformation, and then I also want to see my parent. My parent was just 2 power caret x. Okay, so that's my transformation, and the red is my parent. So you can see that we've been vertically stretched a little bit. We've been reflected in the x-axis, and we've been shifted up 5 units. And so that's what we're going to write on our papers. So our A value gave us a vertical stretch by a factor of 1.7. 1.7 is bigger than 1, so it's a stretch, not a compression. If it was 0.7, that would be a compression. But if it's 1.7, then it's bigger than 1 and it's a stretch. Okay, we have a rocks because our A value is negative. And we have a shift up 5 units. Shift up 5 units. That's it. Okay, number 4. Oh, here, I was just talking about 0.7. So because we have 0.7, that's going to be a vertical compression. Vertical compression. By a factor of 0.7. Okay, the 5 is just our base. It's just telling us if we're growing or decaying, and we're growing. We do not have a rocks because our A value is positive, so no rocks, but we do have a shift. We have a shift down 3 units. And it's this D that gives us that shift down. Remember, it's like the K in a quadratic, it tells the truth. Okay, and you already know how to do this last one. I'm just going to remind you because, we forget. Determine whether the following points lie on the graph of this function. So this is a 4-point problem. Okay, we get a point for the correct answer for each of these, and then we get 2 points for work. So even if we get the right answer, but we don't show any work, we're at a 50%, which is an F. So write down the table, okay? Write it down. So we're going to put these, we're going to put this in the calculator, and we're going to see if these points are on that table. So y equals 0.5x plus 5. Okay. Y equals, clear all this, open parentheses, 0.5, power caret x. Oh, I already forgot. Plus 5. I was on roll with these plus 5s. Okay, so I want my table. And what points am I looking for? I'm looking for -2, 9, and 1, 5.5. -2, 9, I see that one. And I don't see 1. Hold on. 1, 5.5. I see that one too. These are both on there. Whoa. Okay, but I have to copy down this part of the table to show that. So it's going to be 7, 9, 6, 5.5. So it goes 7, 9, 6, 5.5, And this was -2, -1, 0, and 1. So we have this one and we have this one. So this is a yes and this is a yes. Ta-da! That's the end of the notes.